select. Once scales are selected, so draw V. Okay, I am drawing here. So draw V. Now draw IA array. IA array in parallel with IA. Now draw IAXD perpendicular to IA. So IAXD perpendicular to this, let us draw this perpendicular line. Let us mark some point. Let us take some point A. What is this? This is IAXD. We know that XD is greater than XQ in case of salient pole machine. So this length is IAXD and this is perpendicular to IA. Now cut IAXQ from this. So IAXQ, let us take from here till here. Let us take it IAXQ. Cut from this. Now join this point with this. Let us join it and extend it. What we did so far? We have drawn our reference phasor V, and this is current phasor, armature current IA lagging with theta. We are discussing lagging power factor case. So for this case we know it, but we don't know delta. That's why what we did next, we drawn IA array parallel with IA obviously. Now from here we have drawn IAXD perpendicular to this, and from this we have cut IAXQ. Let this point be this, then we have joined this point with this and we have extended. Now next, draw a perpendicular from this point A on this extended line. Let us take this as, let us assume that this meets at some point B. So this phasor, let us say this is O. So this phasor OB gives the EMF E, no load EMF or internal EMF, per phase induced EMF. And now this angle delta is known. On graph paper you can measure it, or directly you can evaluate it if asked in the problem. So both way we have drawn the phasor diagram of a salient pole synchronous machine. For this alternator we can draw, if delta is known, then directly we can draw it like this. If not known, then we can draw like this. Now next, come to the cylindrical rotor machine. So in cylindrical rotor machine we know that XD is equal to XQ is equal to XS. So directly this equation may be written as E is equal to this together IA array, this V plus per phase terminal voltage, per phase induced EMF, this IA array plus J times IA XS. Fine. So for cylindrical rotor alternator we may draw like this. Let us draw V somewhere here. This is V, and we have taken lagging power factor case. So let us take current lagging by some angle theta IA. So from here draw IA array parallel to IA. So we can draw IA array. Then we have to draw j ia axis. Obviously it will be perpendicular to ia. So this is ia. So perpendicular to this will be somewhere something like this. Let us take it as j ia axis. Then we will get E. So join this with O. Let us mark this as O. Fine. This is V. So this will be our E, and this angle will be load angle delta between E and V. So this way we can draw phasor diagram of an alternator, a synchronous generator, for both salient pole as well as cylindrical for a lagging power factor load. Now come to the case when power factor is unity. Now for unity power factor, we know that V and I phasors are in same phase. So we are taking second case, unity power factor. So for unity power factor, we know that V and I will be drawn along same line. So let us first draw V phasor, and again take the two cases, either delta will be known or unknown. So first take the case when delta is known. So once we have drawn V phasor, we may draw Q axis at an angle of delta if delta is known. If delta is known, then we can draw this. Fine. So if this is V phasor, so I phasor will also lie along same direction, IA. So once Q axis is known, let us write it Q axis. It means D axis may also be drawn. D axis. So take the two components of IA, one along D axis and one along Q axis. So this will be ID and this will be IQ. Let us mark it 0 or O. This is IQ. Fine. Now IDRA will be along ID. So from here parallel to this IDRA. Fine. Then IQRA along IQ. So from this we will have IQRA. So obviously this will be IARA along IA. Let us take vertical line. Okay. So somewhere this will be IQRA and this will be IARA. IARA drop will be IDRA plus IQRA. Now we have to add this drop J times IDXD. So J times IDXD will be perpendicular to ID, that is along IQ and along this, and this will be equivalent to this drop IDXD, J times IDXD. So right here J times IDXD. Fine. Now the left over drop is IQ XQ. So J times IQ XQ will be perpendicular to IQ. We know that our E will lie along Q axis, but we don't know at which point we have head of our this phasor E. So from here J times IQ XQ will be cut, and this will be our tip of this phasor per phase induced EMF or internal EMF E. This was the case when delta was known. What about the case when delta is not known? So again the same procedure. Select two scales for V and IA, then draw V phasor. As for this case, unity power factor, we have IA in phase with V, so IA will be somewhere lesser or more, but direction will be same. IA. From here, we will draw IARA drop. IARA drop, as we did in this case, IARA drop. Now, the same procedure, draw IAXD perpendicular to this. So, draw IAXD perpendicular to this. Let this meet